S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Gradient in vectors has a physical significance. In today's video, we will be learning that physical significance. Welcome to S. Chand Academy, and I am Anmol Bhatia. The course that we are studying is Engineering Mechanics, and we are starting module number 2 in this video. For detailed conceptual clarity, you can refer to this book by S. Chand Publishing. The link of the book is there in the description box below. The contents of module number 2 of Engineering Mechanics course are these contents. Number 1 is potential energy function, which is F equals to minus gradient of V, their physical significance, meaning of gradient. Then we have a concept which is conservative and non-conservative forces. That includes curl of the force and central forces. Then we have angular momentum case, elliptical, parabolic and hyperbolic orbits, Kepler's problems, and there are certain applications in the real life situations. Now in today's video we will be learning about this concept which is potential energy function, or you can say that F equals to minus gradient of V. So this potential energy function is basically termed as minus the gradient of V. That means this conservative force, this force is termed as conservative force. What is conservative force we will learn in the coming videos, but as far as the concept is concerned, conservative force is equals to the negative gradient of the potential energy. So V here is the potential energy and this is the negative gradient of the potential energy case. Now what is required, we need to derive this concept initially, and then we will have certain applications of gradient and what is the physical significance of gradient we will learn in the next segment of this video. So firstly we shall derive this F equals to gradient of V. So gradient in this particular situation is termed as delta V, where this delta indicates is I del by del x plus j del by del y plus k del by del z. This del indicates the partial derivative, not the exact derivative. This del indicates the partial derivative. Del by del x indicates the partial derivative. Now what happens here, it is to be noted that when a particle is acted upon by a conservative force, so whenever a conservative force acts on a particular particle, it moves from this space, from this coordinate value which is x0, y0, z0 to another space x1, y1, z1 having a potential energy value at r. So on solving, we have this formula of this potential energy, which is the negative integral of F and dr. This is a product of F multiplied by dr, and it has to move at this location from 0 location to r location. So 0 to r is the value. Now F force and dr value both are indicative of two different terms. So F force is having three segments, which is Fx multiplied by I vector plus Fy multiplied by j vector plus Fz multiplied by k vector, where I, j, k indicates the unit vectors. So I have substituted this value of F. Similarly for dr, dr is the components which is dx, dy and dz in terms of I, j, k. So dr is equal to I dx plus j dy plus k dz. So what I want the value of f and dr, the product of f and dr, so that I put it here and then I derivate it. So f multiplied by dr is required. So f is having this value and dr is having this value. When I multiply them, I will get the overall value as fx dx plus fy dy plus fz dz. So far we got the value of f multiplied by dr, and we will try to put this value in this particular equation. So we got this value, which is fx dx plus fy dy plus fz dz, and f dot dr was required, and the value was from 0 to r. Now what happens? I have told you that initially it was at a point x0, y0, z0, and finally it reaches to the point x, y and z. So this 0 to r is initial point to the final point. Initial point for x component is x0, final point for the x component is x, initial point for y component is y0 to y and z0 to z. It has minus sign, so minus sign in place of every component. Fx into dx is with the separate integral, fy into dy is with the separate integral, and fz into dz it is with the separate integral, and we will integrate them separately from x0 to x, y0 to y and z0 to z. Then what happens? If I derivate it, or if I get the formula for f, I will have this minus I dv by dx, minus j dv by dx and minus k dv by dx. So what I will do, I can take this I as common, because this component can be written as the division of the velocity, division of this potential energy case. So what I can take this v as common, and this particular thing, minus is also common, and this particular thing is called as del. Del indicates the gradient. So initially I have told you what is del. So del was I del by del x plus j del by del y plus k del by del z. So I have this value of gradient, I have substituted this value of gradient, and that indicates del. Del into v is the value of force. That indicates, or that proves the situation that the potential energy function is the negative of gradient of f. But it has a physical significance in the real life situations or the real life applications. That means it basically denotes the steepness of the object. How steep is the object is having the relative velocity. So let us look at the concepts in detail. So we stop here for a short break, and after the break we will learn the concept of gradient in detail. So far we have learnt about a concept which is the concept of potential energy function, and we have derived that. After coming from the break, we will learn about the significance or the physical significance of the gradient concept.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. In the previous video, before going to the break, we have learnt about the concept of potential energy function. Now in this part of the video, we will be learning more about the gradient function, how this gradient function is defined and what is the physical significance of this gradient function in the real life situations. If I talk about the meaning of gradient, gradient is basically related to a scalar field. Now what is a scalar field? A scalar field is basically associates a scalar value to every point in the space. Let's say I have a particular space, and if I measure the temperature values at different locations, I will get the different values of temperature. Let's say at a particular point I have the temperature of 18 degrees Celsius, At a different location I have the value of temperature at 18.2 degrees Celsius or some values. So here a scalar field basically associates a scalar value to every point in the space. This is called as a gradient. So example is temperature. Temperature is basically a scalar value. Temperature is a scalar quantity which is having a fixed magnitude, So this indicates a gradient. Mathematically, if I talk about the gradient, so gradient has a mathematical explanation or a mathematical expression. Here we have a function which is having a coordinate x, y, z. So the gradient of this function, which is del f, that can be defined as del f equals to I del f by del x plus j del f by del y plus k del f by del z. Why this del is there? I will answer to this question. But del indicates here the partial derivatives. I, j, k, I have told you that I, j, k are the unit vectors. So mathematically this gradient is expressed as I del by del x of this function plus j del by del y of this function plus k del by del z of the function. Let us look at the problem to showcase what is gradient. Example is fx yz equals to the product of x y z, and I need to find out the gradient of this value of f. So gradient, as I have told you, it is del f. Del f is I del by del x of this function plus j del f by del y of the function plus k del f by del z of the function, where I, j, k are the unit vectors and f is the indicative of the vector that is given in the question. Now the case is to differentiate the function with respect to x. So if I partially derivate this f function with respect to x, these y and z are constant values, but x is a value which is variable. So I need to derivate it, so it comes out to be yz. So I substitute yz here. Similarly, if I derivate this function with respect to y, what happens? Y would be constant, y would be variable and xz would be constant. So I need to separate them out and I need to derivate y. So it becomes xz. I have substituted xz here. And similarly for z, z would be variable and xy are constant. So I substituted it here. So from there I have found out what is the value of del f. Del f in this case is this expression, which is a vector quantity. Now why this particular gradient is having a partial derivative? Let us understand this concept. Let us have a plane which is a representation in x direction as x, y direction in y and z direction in z, and it is having a point or a coordinate which is having the value p. Now p is changing from x to p dash, from a value which is x, y, z to the value which is changed in x direction, but y and z are same. Here you can see that if this point is moved from here to here, only the x component will change, y, z components would not change. This was the same concept as in the previous question, as I have told you that x is variable and y, z is different. So here also x is variable and y, z are constants. But if I look at the situation, only x is changing, y, z are not changing, but overall function is changing. So if the overall function changes, then in that particular situation we need not to use the total derivative, because the overall function is changing. So if the overall function is changing, for that particular situation we use the partial derivative. That means we need to consider the effect of others also. So this is the basic idea behind why partial derivative in the gradient. Now coming to the physical meaning of gradient. The physical meaning of the gradient is steepest path or the steepest descent of the object. Let us consider a situation in which we have this body, and this body has these three paths. One is CA, another is AD, and the third one is BA. So we consider these three situations. In one situation, let us have a marble, and that marble is moved from this particular in this particular path, and the second is moved from this particular path to this particular path, and from the third one this B path to A path. So the steepest one would indicate specifically the gradient. So here the steepest one would be BA, and that particularly indicates the gradient of that particular function. Function rate in case of gradient should increase rapidly. This is one of the concept behind the gradient part. Now we look at the physical meaning of the gradient. The physical meaning of the gradient is as follows. The gradient of the scalar field is basically a vector field. This is one of the situation to understand. The gradient of any scalar is a vector field at any point which the vector has magnitude, and that magnitude is equal to the most rapid increase of the function f. Before going to the break, we have derived this expression, which is f equals to minus gradient of v, and in that expression we have this f value which is vector. So f indicates a vector quantity and gradient of v indicates a scalar quantity. So I have told you that the gradient of this scalar field, this v is a scalar field, so gradient of this scalar field is a vector field. So here you can see that v is a scalar field and f is a vector field. So if I take the gradient of this scalar, I will get a vector. So this is the situation, and that is equal to the rate of f, that is equal to the most rapid rate of increase of f. Now we look at some more numerical problems based on this gradient only. So we have f as x square plus 2xyz, and we need to find out what is the value of gradient of this function. So gradient, I have told you that gradient of f is I del f by del x plus j del f by del y plus k del f by del z. In different cases, I need to find out del f by del x, del f by del y and del f by del z. So in these three cases, I can find out del f by del x. So I need to derivate it. X square has a derivative 2x, and 2xyz would have the derivative as 2yz, because the derivative of x would be 1. Then we have the derivative of this function with respect to y. So for this, x is a constant, so it becomes 0 plus 2xyz. Here y is a variable, so 2xz is the function, which is df by dy, and then we have the derivative of this f with respect to z, so df by dz. X square's derivative is 0 and 2xyz will have the derivative as 2xy. I have all these three components. I can substitute these three components here in the expression so that del f can be obtained. So del f would be I times del f by del x, which is 2x plus 2yz plus j times 2xz plus k times 2xy. So this is an expression for gradient of this function f. Now let us look at another numerical problem in which a trigonometric function is to be used. So let us say the function is fx equal to sin x plus xy. fxyz is given as sin x plus xy, and I need to find out the gradient of this f. So gradient of f is I del f by del x plus j del f by del y plus k del f by del z. So individually I need to find out what is the value of del f by del x, del f by del y and del f by del z. So firstly del f by del x is to be found out. So it would be the derivative of this function with respect to x. So derivative of sin x is cos x plus the derivative of xy is y. Then I have the derivative of this function with respect to y, df by dy, that would be the derivative of sin x is 0 and xy has a derivative y because the derivative of x is 1. Then you have the derivative of this force as with respect to z. So sin x has a derivative which is 0 and xy has a derivative which is also 0. Now I have all these three terms. I need to substitute all these three terms here in the expression. So I will have this value of del f as I, del f by del x value is cos x plus y plus j, this is y, plus k vector into 0. So this is the final expression for gradient. So we come to the end of this video. In this lecture we learnt about the gradient function, the physical significance of the gradient, and we also learnt about some numerical problems. For detailed conceptual clarity, you can refer to this book by S. Chand Publishing. The link of the book is there in the description box below. If you find the video interesting, like, share, subscribe the channel and hit the bell icon for future updates. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.